Hi everyone, it's Judy. Welcome back to the OnTrack podcast. Today we talk to Carl Schattke, who works for a leading electrical vehicle manufacturer and who has almost 40 years of experience in PCB design. He's going to teach you about the things he thinks about when he's designing very complex boards, as well as talk about what he's going to cover at a keynote that he's doing at AltiumLive in Frankfurt, October 21st through 23rd. He's also going to talk about a talk he's co-presenting with Max Seeley from 3M, where they're going to talk about going from schematic to PCB layout and passing that baton like a champ. You're really going to enjoy this podcast. Before I let you go, you got to get over and sign up for AltiumLive, you guys. It's filling up, space is limited. Beautiful San Diego, beautiful Frankfurt, Germany. You can't lose, and we sure hope you can join us. Meanwhile, lean and enjoy. I'll see you on the other side. Welcome to Altium's OnTrack podcast, where we talk to leaders about PCB design, tackling subjects ranging from schematic capture all the way to the manufacturing floor. I'm your host, Judy Warner. Please listen in every week and subscribe on iTunes, Stitcher, and all your favorite podcast apps. And be sure to check out the show notes at altium.com/podcast, where you can find great resources and multiple ways to connect with us on social media. Well, good morning, Carl. Thank you so much for joining us. We're looking forward to this conversation with you today.
Good morning, Judy. It's nice to speak with you as well.
Carl, I want to ask you a sort of fun question before we get started that I like to ask sometimes, and that is, what kind of things in your childhood would be indicators that you would someday grow up to be an engineer or PCB designer?
I used to play with toys a lot and building blocks and anything that moved. I was very young, maybe 3 years old, and I built a helicopter out of an erector set. And then we went, and my dad and mom were very supportive. My dad was an engineer and my mom was a teacher. And after I built the helicopter, then we went to Golden Gate Park and flew the helicopter, with the bridge in the background.
That's fun.
That's one of my earliest memories of an engineering project.
I can't believe 3 years old. That's quite young to be building a helicopter. Yeah.
Yeah, just grab stuff and start putting it together.
Were you a puzzle person or a person just put things together and took things apart? I'm also very good at puzzles. I usually do about 10 pieces for everybody else's one. We put 1,000-piece puzzles together here in a day sometimes, or 2 days. Wow. Well, very typical. I always like to ask that question to see what kind of breadcrumbs led you to where you are. So thanks for sharing that.
There's one more story I want to relate, and that's when I was around 5, my dad and a good friend of his were working on a project, and the project was a smoke detector for residential use. And at the time, nobody had done that. There was a few commercial systems, but they told me that what they were doing should save lives. It should wake them up when they're sleeping and there's a fire. And that kind of lit the fire for me, because I realized that you could have a really positive impact on people's lives with technology. And that really made a difference to me. I was incredibly impressed at how important a project could be, and I'm sure that saved many lives with what they did. And I just find that to be a tremendously exciting thing to do. And it's just still exciting, even all these years later, working on projects that benefit people.
Yeah, that's great. I love that. So tell us a little bit about your professional background and how you got to kind of where you are today from a professional standpoint.
So, like I said, my father was an engineer, and he was a mechanical, electrical engineer, mostly doing mechanical projects, but then he was doing printed circuit board design, and we used to tape printed circuit boards back in those days, and he would have a light table and he'd have the tape, and the knife and be drafting things up and cutting them. And so I grew up around him doing that. He did a lot of moonlighting. I would see my dad working like that, and obviously a curious child, you're always looking over your dad's shoulder and asking questions about it. And so I grew up around it, and then my dad started a printed circuit board design company. I was probably 8 at the time, and I would help my father with point-to-point continuity checks. When we would finish a layout, we'd actually run it through a blueprint machine, and then we'd have a blueprint of the artwork, and one side would be a little bit darker than the other. My job was to take the yellow pencil. He'd call out the schematic, and I would call out where it went on the printed circuit board. So he'd go U1 pin 6, and I would go U2 pin 3, and then he would go U2 pin 4, and I go U1 pin 7, and we would just talk like that for hours if we needed to.
So you were doing a manual netlist check, kind of.
That's exactly how we did it back then. It's it was way faster if you had 2 people doing it. And my job was to color the blueprint with a yellow pencil so that when you were done and the schematic was all checked out, he would be yellowing out a copy of the schematic, and I'd be yellowing out a copy of the printed circuit board. And there should be everything should be yellow when you're done. If it's not, that's extra or it's a mistake or something. And obviously when we found an error, then we'd get the red and green pencils out and we'd draw what it was supposed to be on the correct layer and fix it. And oftentimes those little changes I would do, and that's how I started doing printed circuit board design. Was my dad had several designers working for him, and I would check their designs, and after a while you got to feel for, wow, this is incredible, or ooh, that's not so good.
Right.
You really knew. And because I saw so many designs, it really helped me develop my own design style and appreciation for good symmetry and spacing and, that kind of thing.
Right. I didn't think of asking you this before, but I want to ask you now is, what do you think maybe the advantages of having that sort of manual, when you were doing tape ups and checking net lists in a very manual way versus somebody that's learning to do PCB design right out of the gate with powerful tools and sort of not having that, it kind of runs in the background to do a net list check, how does that impact you?
One of the things that it does is it gives you an appreciation for using the space that's available. And the floor planning was almost easier back then than it is now, because we would use paper dowels, and I would color the pins of power nets and ground nets, and I would color all that, and then I'd just be moving pieces of paper, and I could move paper quicker than I could move a mouse, I think. So in that sense, it was a little bit easier, to a certain degree. But today's boards are so complicated and have so many different things going on that I would have been super hard pressed to do anything close to what we do now. But
right.
There were some incredibly intense designs back then, with several hundred parts and thousands of connections. It might take 2 months or 3 months to do a layout back then, by hand, and and that's heavy hours working a lot. But I did a ton of telecom boards back in those days. That was a lot of the work that I did back then was telecom boards.
Yeah, which were the harder boards, really. I mean,
they were definitely challenging, and you were always limited to either 2 or 4 layers, and the 4 layers would usually be a core that was already done, and they'd pre-plan. Everything was ICs at 0.3 inches from lead to lead or 0.6 inches from lead to lead, and you would either span 1 or 2 gaps, and they put columns of space for the pins, and then at the end of each space would be area that was either for the ground plane or the power plane, and you would drop a via to that, and And that's how you made your connections and had a multi-layer circuit board, was with like a core board that was already designed. And you would use that core to do the outer layers. All the routing was on the outer layers.
Interesting.
I did several hundred layouts like that, hand taped. That was just how we did it up until the mid 80s when.
Yeah. I was around when some of that hand taping went on. I've shared it before, but I think I'll share it here in the show notes again. I have a picture of Rick Hartley on a light table laying out a pretty complex design, with the red and the blue tape, and of course then it was greatly reduced right after you laid it out. So
this is one of the rulers that I used. I don't know if you can see it, but it's a 2-to-1 scale on this side.
Oh, okay.
4-to-1 scale on this side, and that's because we did the artworks at 2-to-1 or 4-to-1. If it was a real dense circuit, we'd go 4-to-1. But if it was a regular circuit board, we'd go 2-to-1. And our minimum line width was 15 mils, because that was the smallest Bishop Graphics tape that we could get a hold of. And at 2-to-1, that would reduce to a 7.5 mil trace. And at 4-to-1, it reduced to like a 3.75 mil trace. So that was. That's how we did it. And then your design rule checking in those days was to, drop this ruler on it and see if you had the right spacing. And when you had a complicated connector or something like that, you would literally like measure out each pad, and the X's this and the Y it's this, and you'd go through and make sure that everything's in the right place and the right size that way. That was design rule checking in those days.
That's interesting.
We've advanced.
Yeah, everything was so manual, and I wish we could still get a hold of Bishop Graphics tape and vellums and let some young designers just experience what that was like. Right?
I should bring one to San Diego with me so people could see it.
Yeah, that would be really fun.
I have one of the artworks I did back then. I threw most of them out thinking that nobody's ever going to need these, and of course you can sell those things for lots of money now.
Funny.
I had drawers and drawers and drawers full of them, and so what do we need that for?
Exactly. And I know, but
so
anyways, bring it. I think it's fun for us to expose younger designers to that kind of history. I think it helps them appreciate things and. Kind of jaw-dropping that you used to do that by hand. Well, moving along, we're delighted that you've agreed to be a keynote speaker at AltiumLive in Frankfurt this year. And you're going to be talking about what as the keynote talk?
My title is Making Rules and Breaking Rules. And I'm going to talk about design rules and where we came from with design rules and where we're going with design rules and where we are right now. And I'm going to talk about how we use them, and I'm going to try and give context to the rules. I'm not necessarily going to train on every single rule that there is. In an hour-long talk, you're not going to do that in a meaningful way, but I am going to illustrate a lot of different aspects of the rules and how we think about the rules and like what's important about this rule. Do we have to make that rule and keep it, or, is this a rule we can break and change and either disregard or do something different? If I get a DRC error, do I fix the DRC error or do I break the rule? And change the rule. And part of the wisdom that comes from doing a lot of boards is knowing when to do that and when not to do that. So I'm hoping to share that with the audience so that they get an appreciation of the thought pattern behind, solving the DRC checks at the end. Because, even myself, at the end of the design, there's a lot of DRC checks to fix, because as you're going through and routing the board, you're more interested in completion than perfection. And then at the end, obviously, we're searching for perfection in our design, and we go back and fix all that.
This is sort of a broad question, Carl, so answer it if you can. In what ways do you think design rules help or hinder today's PCB designer?
Well, they're a tremendous help. The clearance rules Altium has a shadowing feature where you start to route and it shows you what clearance you have, that's set up in your clearance rules. That's pretty awesome because it's different. For high voltage, you can set a different rule, and that's pretty awesome. There's rules with length matching. It'd be very hard to do the work we do without the advanced rules that are part of that. Now, part of having those rules is also understanding what the gaps are. So, when we finish a board for a high volume, it's typically going to be submitted to a board shop and an assembly contract manufacturer, and they're going to go through that and do a DFM on it. And they find stuff that we don't find. Like, we send it out thinking it's great and perfect, and they come back with, "Oh, we'd really like you to change this or balance the copper, or do something like that." And their experience is, we would like to do this to give you a more reliable build to get higher yields and things. So ultimately, the value of the rules is to get a higher yielding board. So when we build products for commercial reasons, they're profitable. Like, that's a really important aspect of the design rules. They allow us to be profitable in building the printed circuit board, to not have low yields. There's a reason that we do these clearances and spacings, and ultimately, like, that's the greatest value of the rules, is to get a board that's easy to produce, mass produce if need be, and then do so in a cost-effective manner that's going to be easy to produce.
And reliably, too, I imagine, right?
The reliability is definitely impacted by clearance spacing. There's ions want to travel. They're energized little molecules, and they want to travel. Like, their high voltage will draw them across. There's dendrite growth. There's calf, which is, like, those things matter. And the farther we space things apart, in general, the more reliable our board is going to be. But we also have to package things in the minimum amount of space, and the smaller we make it, the smaller the board, the less we pay for it. So there's a dichotomy in design that has to be solved. It's like, make it right, but don't make it bigger than it needs to be. And like, that's one of the great things of our profession, is we get to solve that problem.
Yeah. Mike Creedon talks about, when he defines design, one of the key markers in his mind is solvability, right? Is that we have to be able to solve that problem, right? And again,
absolutely,
right?
And the density of the boards, I'm pretty confident if I can get the parts on there, I can get it routed. But if there's a wide bus or something like that, I need to consider that like I would a component. Like, where is that going to route? What's my channels? And when I set it up, I look to organize things in ways that are simple, that generally is going to result in the most elegant design.
Well, I really liked, I think I'm going to share this in the show notes too. I love your perspective there, is that you realize that you're a partner with your fabricators and that they're going to catch things, even with all your years of experience. As for me, coming from the manufacturing side, both from assembly and bare boards, I really appreciated when our designers worked well with us, right? And especially the sooner the better. And last year you did a talk at AltiumLive with Julie Ellis from TTM, and you kind of really gave a really legs to that concept of working together, because she, being an FAE, working on stack-ups together, right? And making sure that it worked not only functionally, but that it was manufacturable, right, long term, and how you work together. And sometimes you just, for speed or whatever reason, that disconnect happens, right? And
there's a lot of reasons, that there's a lot of reasons for disconnects. And I think, one of the most important tools engineers have is the ability to communicate with, their partners in manufacturing and in engineering, and to ask the right questions. It's like, what about this design is hard for you? What's easy? getting feedback is, a loop that's not always closed, because as soon as we're done with one project, it's almost always right on to the next.
Yep.
The timelines of business are such that we're always doing something, and it's always a hot project. That's just the nature of what we do.
Yeah.
And, getting a chance to reflect and then learn is extremely valuable. If I don't consider the errors a problem, I consider them feedback.
Right.
Like that's my mindset about, being notified of something that's wrong. So, okay. And sometimes I'll push back, if some suppliers are like, I need you to change that footprint. And I'll be like, we're already using that footprint with like 8 other boards and 6 suppliers. We're not going to change that. Like that works perfectly, make it work. Or, they might say something like, we need to change this. And I'm like, oh, that makes sense. And we'll do it. Like that. When you get a TQ, technical query back, and you go through those things, and, you're either like, I like that, or that makes no sense at all, for what we're trying to do, And
I think when it's done well, it provides feedback on both ends, because I don't think the manufacturer is always the right one necessarily, right? They're just looking at a different set of optics, right, for their own goals, right?
Yeah, absolutely. Like, sometimes I'll hear like, put this connector on the other side of the board, and they're like, well, that would be nice, except there's a display on that side of the board, and this thing won't work if we do that. They don't know the answers, they don't know the environment. They see the printed circuit board, and they're like, you'd save money if you put this part on the other side. I'm like, yeah, I know, but it wouldn't work then.
Yeah.
Nobody would be happy with the result if we did that.
Right.
So, sometimes it's like that.
Speaking about collaboration, you are also doing a breakout session, a 2-hour breakout session with Max Seeley from 3M, both in San Diego and in Frankfurt at AltiumLive, which again, I just think is wonderful. Can you tell me, did you and Max actually meet at AltiumLive? I know you both have been there the last few years.
That's where I met Max, was at different events. We've both been going to different events for years, and we've known of each other. And then when we were in Munich, we spent a little bit of time together and got to know each other better. So I'm totally comfortable working with Max remotely on this and making it happen. And I think it'll be even. He's a very good engineer and a very good designer. At least I like to think so. And I think what's going to be really useful is to go through the process of how you move a design from schematic to PCB, and then we're going to talk to that process, and we're going to go through a number of different circuit types, and I'll ask him questions, and he'll respond back, and it'll be like that dialogue of starting a printed circuit board, and how do you get going through that handoff of transitioning from the schematic to the board. And I think it's going to be really valuable for a lot of the members of the audience to see, how do 2 professionals go do that? Sometimes just being in the room gives you a lot of insight. And I think it'll give us a chance to, highlight like some of those things that aren't written in the tools or not written in the rules. You don't see videos on it. It's just like something that's really, really important. And, it's just something that, hopefully the people that see this, they will ask those same questions when they start their board design, or if it saves a serious error, saves you from going down a dead end street, that's valuable. I think everybody's going to get a lot of value out of our talk. That's my hope.
I'm absolutely confident of that fact. And again, both you and Max operate a very high level within 2 very large companies, and have surrounded by design teams and in a very dynamic environment. So I think you're exposed to a ton, like rapid fire, right? So it's not like you guys design 2 boards a year or 4 boards a year. Right?
It's usually like a week. Certainly a month.
Right, exactly. So, and again, that speeds up the learning curve. And so I think for people to be able to hear from you, really your combined experience is really good. And also, we talked about this when we got you and Max on the phone. So for our listeners, the name of the talk is Schematic to PCB Design, Passing the Baton Like a Champion. So it's that handoff, right, between the schematic. Sometimes you're passing it to yourself, right? Because a lot of EEs are laying out their own boards. So
yeah, those are the guys running two legs in the race,
Right? And so tell me how you think for those people this talk will be beneficial.
Well, I think they're definitely going to have the same issues and problems, whether they hand it off to some other person or themselves, but they still have to think about all the aspects of that process and to think about, like there's going to be value for them too, depending on their experience level. We're going to be covering a lot of different circuits that, are, you could go into the design app notes and, learn, what that vendor thinks is important. But the engineers, if they're designing the components, hopefully they have a really good idea what they're looking for in the layout. But engineers that do layouts typically struggle with layouts. I would just say typically, not all, but typically, like it's a lot more work than they want to deal with. Usually they'd rather hand it off to somebody that's competent. That's my experience. It's like, yeah, they're really good and they're really talented, but usually if they're that really good and really talented, they're being tasked to come up with more really good designs, generally.
Yeah,
designers are typically better at constructing, the printed circuit board, and certainly better at documenting it and, that kind of thing, and watching out for manufacturing gotchas and things like that. Typically, the engineers are not designing a highly manufacturable board from a printed circuit board designer standpoint. We would, not always, like some engineers have done a lot of layout, but generally, somebody that's an experienced designer is going to be watching out for things that they're not typically watching out for, just because it's not on their purview.
Well,
it's off their radar. They're like focused on the circuit.
Yeah.
But you have to be focused on the circuit and be focused on, I have a design package that has to be handed off, and they need to be able to build it without question. And that, is something that typically a board designer is more trained to do. I have a CID plus certificate, and, those are the kinds of things that come up in that kind of training, and like how do you make a board that's manufacturable, and that is something that typically the board designer is going to excel at, and the engineers are going to they can be very experienced at that too, but typically they'd rather hand that responsibility off to somebody who has that in their wheelhouse on a regular basis.
Do you think, I have my own conjecture on this or opinion on this subject, do you think, pure electrical engineers who do circuit design versus a PCB layout pro, do you think they kind of are wired a little bit differently, or using a different part of the brain, or do you think it's the same?
The challenges are going to be the same for both. Like it doesn't get any easier to do work if you put a title near your name. Like it's still the work.
Yeah.
If you have a title, graduate PhD engineer, that doesn't mean that you know all the aspects that are important to a printed circuit board design. It all boils down to, transmission line theory, resistance, capacitance, inductance. How do those things work together on the circuit board? How do we minimize what we want to minimize and maximize what we want to maximize? And those are the things that typically a board designer's thinking in terms of in a 3D way. Like, the signal integrity, we're thinking about that as we do the design. And, it's going to depend a lot on your experience. Like what have you done wrong that people told you about in the past? And, like those are the scars that harden your skin up, as you move along. It's like, oh, they didn't like that one and I had to redo it. Oh, that was a lot of work when I didn't remember that. So, when you go through your next design, it's like, don't want to do that. That was a landmine. And, when we give our talk, the idea for us is to warn people about those landmines so that when they step into a new territory that's maybe a little different from what they were designing, it'll get blown up. It doesn't come back and, have to be redone. There's no reset button. Once the board's done, changes are hard. You have to cut the traces and put blue wires on. And I don't know any engineers that like that. I don't know any techs that really like that, even though they can be pretty good at it. Everybody would rather have a design that's, blue wire free and, ready to go. And our goal with our talk is to help people avoid that scenario. Just design a little bit more reliable board, design the process in a way that's going to get a design completion that's more likely going to be successful. So our goal, from our talk is to share different tips and tricks and, methods that we've found for accurately designing printed circuit boards in a way that's, going to make them more manufacturable.
Yeah, that sounds so valuable. I'm so excited you guys are doing this.
After, in our talk is to, just really share those kinds of insights with people. Like, oh yeah, this is an area you want to watch out for, and these are the things that we watch out for as experienced designers. Like, this is, we've seen problems here. This is why we're telling you about it. So we want to spend our talk sharing those kinds of scenarios with people, and talking through the details of like what's going to be effective. We're going to cover a lot of different areas.
Real quick, just overview. What are a few areas where you see sort of the baton being dropped in that handoff?
Placement expectations. So, ground planes, the placement areas, like how do you arrange that? I see details dropped, like what's the right side of the board? Like, is this the top side view or the bottom side view? Like, simple stuff like that is often where the problems are. But also, just like not laying out a circuit in a way that's going to be optimal. What are, not, leaving off the timing requirements for something, or not specifying something, in the rules that, could become a design rule, leaving like differential pairs unlabeled as differential pairs or something like that. There's a lot of little details in design that matter a lot. High-speed circuits aren't going to work without the right length matching and the right, signal integrity. So we're going to cover, like, how do you share that information with people in a way that's, effective for your time and for the designer's time, and, gives everybody a real clear understanding of what's needed. So we're going to cover that for a lot of different circuits. Hopefully we get a chance to talk about, magnetics, and we get to talk about high speed, and we get to talk about power integrity, signal delivery, just the general nuts and bolts of bringing a design in, talk about hierarchy. We'll talk about, different ways to set up the schematic that, make it easier for the board to, design or understand, and just generally, like, how do you do these things? Like, what are some of the things that are in the tools that allow you to do that better, and then what are some of the things that verbally should be talked about? So those are the kinds of things that we want to go over, and we're going to be doing that like an engineer and a designer would. Like, that's, we're doing this, we live a couple thousand miles apart from each other, but we're still going to, when we come together, we're going to do it, and it'll be authentic, like design review. Like, that's the goal, is to just go through that process of how do you transfer design from the schematic to the board, and then ensure that the engineer's getting what he wants. How do we lay out the clock signals, what's important for ground references, and things like that are not typically put on a schematic. Like, what's the ground plane? Nobody drops that onto their schematic. Like, how do we treat transitions, from one layer to another? Like, that's typically not something that's treated. Like, where do we place these capacitors? How do we go about it? What's the most important one? Like, all of this kind of stuff is really important to getting the best design designed. And we want to cover that. Like,
Are you sure you can fit this in 2 hours? This sounds like a lot.
Oh, we're gonna nail it. I know we will. Usually it's about that long a process, and we'll bring a big bucket and we'll carry as much out as we can.
That's awesome. I'm very excited again because you guys are flying hard and fast every day. And so to get this level of, an engineer and designer, and, something Max has shared with me is that sometimes just because of the speed of the work, right, that he'll get in a season where he'll just be doing schematic. And then he feels like he gets a little, he loses his edge on the design. And he kind of gets hungry to get back in the design because he wants to keep those skills sharp. So I think it's going to be fabulous. So I'm going to ask you one last question before we sign off, Carl. I know, because I know you and you're a dear friend, that you work nights. But when you do have time off, this is called Designers After Hours. What are some things you enjoy doing after hours when you actually have some after hours?
I play games a lot. I do online gaming, and that's something that I enjoy. It's just something that it helps me unwind. After a day, I come home, I play games, and then it's probably affects my sleep more than it should. But it's just something that's I haven't always done that. I just find it relaxing. Like, it's a little bit of time for me. Like, the family's in bed, the work's been done, and it's just a little way to relax for me. But I also like to do physical things too. I'm a martial artist. I like to do some martial arts every day. It's just a good way to get my blood moving and stay flexible and strong.
That's fun.
That to me is like, you want that physical. Most designers are sitting there butting a chair for a lot of hours, and we got to lift our tail out of the chair and move it around. Like, that's really important to maintain our health. And for me, that's martial arts, and I like to do bicycling too. But there's and yard work is a thing that I like to do as well. Is just get out in the garden and make sure the flowers are blooming.
Yep, sounds great. Well, Carl, can't thank you enough. This has been a really rich conversation, and I know that both your keynote in Frankfurt and then your talk with Max Seeley in both San Diego and Frankfurt are going to be highly valuable, and we thank you so much for your contribution. We know you're passionate about design, and we appreciate your generosity of spirit to share all your knowledge and experience with the Altium community. So thank you so much.
Thank you, Judy.
So to our listeners, thank you so much for tuning into the OnTrack podcast today. You can bet that I'm going to pump up AltiumLive right now. It is a wonderful experience to get face-to-face with people like Carl and Max and a whole litany of other people. I really encourage you to go. San Diego's only, 5 weeks away or something. It's getting really close. We do have limited space, so please, I hope you can join us if you're able to get away. And San Diego's October 9th through 11th in beautiful sunny San Diego here on Coronado Bay, and then in Frankfurt October 21st through 23rd in Frankfurt, and we're at the Frankfurt Sheraton Hotel, which you can literally walk from the gate at the airport into the hotel. So it's convenient. It's a lovely part of Germany. So we hope you can join us live. If not, keep your eyes and ears open. We will be recording these. I'm not sure when they'll come out, but live is always better if you're able. So thanks for joining us today. Please remember to like, subscribe, tell us what you want to hear more about on the OnTrack podcast. We are always grateful for you listening. I want to give a shout out to Andreas from Spain, who sent me a lovely note this week that said he listens to the OnTrack podcast while he's designing in Altium Designer 19. So he's learning about design and design for manufacturing while he's laying out boards. So thank you, Andreas, for listening, and all of you out there. We'll see you next time. Until then, remember to always stay on track.